Functions of a DBMS. In this section, we'll look at the types of functions and services we would expect to be provided by the database management system. Code lists 8 services that should be provided by any full-scale DBMS. First one is the data storage, retrieval, and update. A DBMS must furnish users with the ability to store, retrieve, and update data in the database. This is the fundamental function of a DBMS. From the discussion in this section, clearly is providing this functionality, the DBMS should hide the internal physical implementation details, such as file organization and storage structures, from the user. A user accessible catalog. A DBMS must furnish a catalog with which description of data items are stored and which is accessible to users. A key feature of an Spark architecture is the recognition of an integrated data dictionary to hold data about the schema, users, applications, and so on. The data dictionary is expected to be accessible to users as well as to the DBMS. A data dictionary or catalog is a repository of information description the data in database. It is the data about the data or metadata. Transaction support. A DBMS must furnish a mechanism which will ensure that either all the updates corresponding to a given transactions are made or that none of them are made. A transaction is a series of actions carried out by a single user or applications program, which access or changes that contain contents of the database. Accuracy control services. A DBMS must furnish a mechanism to ensure that the database is updated correctly when multiple users are updating the database currently. One major objective in using DBMS is to enable many users to access shared data concurrently. Concurrent access is relatively easy if all users are only reading data, as there is no way that they can interfere with one another. However, when two or more users are accessing the database simultaneously, and at least one of them is updating data, there may be interference that can result in inconsistencies. Recovery services. A DBMS must furnish a mechanism for recovering the database in the event that the database is damaged in any way. When discussing transaction support, we mentioned that if the transaction fails, the database has to be returned to a consistent state. This may be a result of a system crash, media failure, a hardware or a software error causing the DBMS to stop, or it may be the result of the users detecting an error during the transactions and aborting the transaction before it completes. In all these cases, the DBMS must provide the mechanism to recover the database to a consistent state. Again, we will discuss recovery control in this chapter. Authorization services. A DBMS must furnish a mechanism to ensure that only authorized users can access the database. It is not difficult to imagine instances where we would want to protect some of the data stored in the database from being seen by all users. For example, we may want only branch managers to see salary-related information for the staff and prevent all other users from seeing this data. Additionally, we may want to protect the database from authorized access. The term security refers to the protections of the database against authorized access, either intentional or accidental. We expect the DBMS to provide mechanisms to ensure the data is secure. We will discuss security in this chapter. Support for data communication. A DBMS must be capable of integrating with communication software. Most users access the database from terminals. Sometimes these terminals are connected directly to the computer hosting the DBMS. In other cases, the terminals are at remote locations and communicate with the computer hosting. The DBMS offer a network. In either case, the DBMS receive requests as communications message and responds in a similar way. All such transactions are handled by the Data Communication Managers or DCM. Although the DCM is not part of the DBMS, it is necessary for the DBMS to be capable of being integrated with a variety of DCMs. If the system is to become commercially viable, even DBMS for personal computers should be capable of being run on a local area network so that one centralized database can be established for users to share, rather than having a series of disparate databases. For each user, this does not simply that the database has to be distributed across the network, rather than users should be able to access centralized database from remote locations. Integrity services. The DBMS must furnish a means of ensuring that both of the data in the database and changes to the data follow certain rules. Database integrity refers to the correctness and consistency to stored data. It can be considered as another type of database protection. While it is related to security, it has wider implications. Integrity is concerned with the quality of data itself. Integrity is usually expressed in terms of constraints, which are consistency rules that the database is not permitted to violate. Services to promote data independence. A DBMS must include facilities to support the independence of programs from the actual structures of the DB database. We discussed the concept of data independence. Data independence is normally achieved through the view of subschema mechanism. Physical data independence is easier to achieve. There are usually several types of changes that can be made to be physical characteristics of the database without affecting the views. However, complete logical data independence is more difficult to achieve. The addition of the new entity attribute of relationship can usually be accommodated, but not the removal. In some systems, any time of change to an existing component in the logical structures is prohibited. And the last one is the utility services. The DBMS should provide a set of utility services. Utility programs help the DBA to administer the database effectively. Some utilities work at the external level and consequently could have been produced by the DBA. Other utilities work at the internal level and can be provided only by the DBMS vendor. Example of utility of the later kind are import-export facilities, to load, unload the database from to flat files, monitoring facilities to monitor database usage and operation, statistical analysis programs to examine performance or usage statistics, index recognition facilities to reorganize indexes and their overflows, garbage collections and reloc- reallocations to remove deleted records physically from the storage devices, to consolidate the space released and to reallocate it where it is needed.